Is it really?
Yeah, there is. I was just kidding.
You. That was on. That was recorded as well. Maybe I'll get another subscriber. All right. Here we go. So I'm gonna round it. I'll write it down. You can start to get the gear shift in there, how to figure out how I did it. But here we go. So the answer, the real answer is, the correct answer is 0.263 meters squared. So that's the correct answer. Okay, I'll give you another one. Let's take 0.0782 liters. Let's divide it by 2.345 liters. Okay. Yep. Okay. So if I divide that, here we go. 0.0782 divided by 2.345, I get, again, here's the whole number. The entire number would be a better way to say that. 3,3,475,4,7,974 liters. The real answer, when you round it, according to the rule you haven't learned yet, round it to 0.0333 liters. I'm out of room, so I'm going to give you one more example. See if you can make sense of this. Never mind, change my mind. Let's make sense of it right now, because I don't want to talk about it if it's not written up there. That's confusing, especially for maths. Okay, does anyone think they know what I'm doing? Thomas thinks he knows. You got to share it.
Oh. Yeah, rounding it to the first 3 sig figs.
Oh, because this is 3 and that's 3?
Yeah.
You think the key is 3?
Yeah.
No, sir. I mean, the key is 3, but not every problem is rounded to 3. I just happen to do it that way. Actually, I did it on purpose because I'm a little bit of a jerk. But you're on the right track. It's not always going to be 3. It just happened to be 3 here and here. Anyone want to elaborate?
Shoots.
Here's the wrong answer. So the wrong answer for this one would be 0.2631. That's the wrong answer. This one, the wrong answer would be
Aren't you just?
0.03335. By the way, this 4 becomes a 5 because that's a 7. I hate that I have to say it, but kids make rounding mistakes all the time. You should be able to round at this point. All right, this is a 1 because that's a 5.
You're rounded.
Okay, that's wrong. That's wrong. Obviously, the 2 circled are right.
Why don't you just tell us?
Oh.
Because that's not fun. I will in like a minute if someone doesn't get it. So we gotta move on.
You're just making the answer shorter.
Making the answer shorter. That's
Right.
sort of what I'm doing.
Not writing out the whole thing.
How many sig figs here? 3. How many here? 4. How many here?
You're just
How many here?
taking one off.
Use the first number.
How many here? 3. How many here?
4.
How many here? How many here? Okay, again, I did this on purpose because I'm a little bit of a jerk. The rule is always round your answer to the lowest number of sig figs. That's the rule. We're going to write that down, but that's the rule. And I'll do one more example with you, then we'll get into the periodic table stuff because I want you to practice this tomorrow. So because this number has 4 sig figs and this number has 3, you round it to 3. Because this has 4 and that has 3, you round it to 3. I'll do another example where it isn't 3, okay, so you can see the difference there. But the rule is round it to the lowest number of significant figures. Which is a little confusing to me, even though I teach it. Why would that not make sense? What are you doing to that number? You're making it less significant, less accurate. But that's the rule. Okay, so the rule is round the answer to the lowest number of sig figs. D, is this on the screen? Or Amanda?
Yeah.
Okay. Now, I actually do know the answer. I'm just throwing that out there to you. I do know why you rounded to the lowest number. Can anyone think of why?
It's just easy.
You ever hear of the quote, "You're only as strong as your weakest link," right? So, to use a basketball analogy, if I have 5 players out there and one guy keeps getting smoked, that guy is killing us. So our team can't do well until he starts playing better. Fair enough? Okay. Hopefully you follow me. If you don't understand the basketball analogy, I apologize. You'll get used to it. So if you're making 2 measurements and one is less significant than the other, and then you're doing a calculation with them, your answer can really only be as accurate as that less significant measurement. Does that make some sense? So if you have 2 measurements, one's more accurate than the other, but you're combining them to get one answer, you can't really rely on the more accurate number. You have to rely on the weakest link. That's really how strong that number is. That's the validity of that number is based on your weakest number, or your less accurate or less significant. So that's why you do it that way. Not super exciting, I know, and maybe not even a whole lot applicable to your life, but that's the reasoning behind it. Okay, one more example. Okay, so let's go with, I'll try and keep it very simple here. If we have the number 100.00, give me a unit. Centimeters. Let's multiply that by the number, I don't know, let's go with, I'll make some weird number up, 269.843 centimeters. There we go. So that's our example there. What's the lowest number of sig figs out of those 2? 5. Right. So the real number here, 269.843 centimeters squared. That is like the number that is right on the calculator, but that's got six significant figures. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5, 6 here. This we need to round so it has 5 sig figs, right? 5 sig figs. That's confusing in your notes, sorry. But 5 sig figs would be 269.84. So we would leave that 4, chop off the 3. That's 5 significant figures. That's how we do this, okay? So I'm going to give you a couple worksheets to practice this tomorrow. I think I'm also going to give you a worksheet with adding and subtracting. I don't have time to explain it. We are going to go to our notes and go right to the bell with the periodic table. But I'll let you try and use the worksheet to figure that out. Worst case, everyone gets confused, I got to reteach it. No big deal. Give it a shot. All right, periodic table. We left off talking about carbon. Someone check their notes. I believe it's carbon. Okay, so again, I'm going to go right to the bell, so stay with me. All right, so carbon, found in all living things. I think I wrote there's 3 allotropes. Did we define allotrope? Yeah. Okay, it's the same element, but the atoms are physically arranged differently. There's 3 allotropes. There's graphite. What's the other 2? Diamond and buckyball, right. Okay, so the way these are arranged, like physically, the atoms, changes what it looks like, what it feels like, how it reacts, so the properties. What color is graphite? Grayish black, right? What about diamond? Clear, looks like glass or a crystal of some sort. And buckyball looks like soot, okay? So all 3 look different, and we use these for different things. What do we use graphite for? To write with, right? What do we use diamond for? To look pretty. About it. And we also use diamond to cut through things, diamond-tipped saw blades, stuff like that, drills. All right, it's because it's very, very hard. Is graphite hard? No, it's pretty soft and slippery, right? Buckyball I believe, well, anyone ever hear of like, nanoscience? Nanoscience?
Yeah.
The term nano means really small, right? I know that's involved with some nanoscience of some sort. I should probably have one right off the top of my head for you. Can't think of an example right now. But you're not using buckyball on a regular basis. You might see these on a regular basis. Maybe not diamond, but you might know someone who has one. Graphite, definitely. All right, so let me, if I can show you this before we get out of here, what these actually look like. Lights, please. So I'll show you graphite, diamond, and buckyball. Then Wednesday we'll have to finish up the notes. There's not much left to talk about. Okay. So the first thing here is diamond. Oh, you're killing me. Nope, this is not it. What just happened? There it is. Okay. All right, so this is what diamond looks like right here. Okay. So what's that shape? Hexagons, right? A bunch of hexagons, like billions of them, all connected by chemical bonds. Each little sphere is a carbon atom. Each little stick in between them is a bond, a covalent bond. So they are bonded, very rigid shape. And what happens here is if you keep building it and building it and building it, it just gets bigger. And that is essentially what diamond looks like, okay? Kind of like if you're building like a giant skyscraper without walls or windows yet. All the beam work and everything, very rigid. So that's diamond. Graphite, from the top, looks like that. Again, the hexagons. This is a double bond. Supposed to be stronger than a single bond, and then there's even triple bonds too. But graphite's actually weaker than diamond. And the reason for that, and I'm going to run out of time, but that's okay. The reason for that is this is how graphite looks. It's arranged in sheets. So what you were just seeing was the above view, like a piece of paper. This is like the side view of a piece of paper, right? So all these sheets are layered. What's in between these two? Nothing. There actually is. It's called a weak force of attraction. So graphite, when you write with it, the sheets just break off. That's why it's much weaker than diamond. Okay? So I'll talk a little bit more about this Wednesday real quick. Here's buckyball. Looks like a soccer ball. So that's buckyball. Okay? 60 carbons or 180 carbons or 90 carbons all in like a big sphere. Very small, but a sphere. We'll talk more about that on Wednesday. What? Oh yeah, video.